Good morning to all. And today we will be continuing the balancing of rotating masses. Last class we learned how to solve a problem when balancing of several masses were acting in the same plane. So today we will be dealing with balancing of several masses acting in different planes. So here, let's say there is a shaft rotating with angular velocity omega. Even though we don't require omega for solving numericals, we have masses rotating at different planes. Earlier it was all in same plane at different angular positions. Now it is at different planes. Let's take these three masses. Let's call it A, B, C. These masses are, when we see from this side, these masses will look like this. A, C, and B. This will have some theta value between them, or alpha, something angular position between them. But in addition to this, there will be distance between each of the planes acting. For example, when we draw lines from where this mass is acting, if I draw a line, this is the plane of action of B, and if I draw another line, this is the plane of action of mass A. Similarly, this will be the plane of action of angle C, and there is a significant distance between these planes. So in addition to the angular positions, you need to find the distance between these planes also. So we, in this solution procedure for numericals, you require this angular position figure, that is figure 1, and in addition to that you also require planar position of planes, like plane of action of B, plane of action of C, plane of action of A, B, C, and you need distance at least between these planes, or distance from a single plane to other planes. And in addition to this, we have to place balancing mass. So balancing mass may be acting at totally different planes. So in the question it will be mentioned that balancing masses has to be placed in plane such that that plane is from a distance, let's say A from the first a mass A, and let's say it is B from C. This distance will be given. You have to find the magnitude. And how do you do it? That is, earlier we constructed a table only involving, let's construct the table again. First column was mass. Second column was centrifugal force divided by omega. Fc divided by omega square, that is m into r. Kilogram meter was the unit. Okay, so in between this there was a radius also. Mass, then radius. Okay. First column was mass in kilogram. Second column was radius of rotation, r in meters. Then Fc by omega square. So here, in addition to that, there should be length from a reference plane, L in meters. And since it is a angle of rotation, angle of, when some force is separated by a distance, there will be a moment. So it will be m into r into L. this force component multiplied by this length. So this force component multiplied by length MRL, that is kilogram meter square. All these 5 columns should be there, and this reference plane is important. You see in this diagram, either there will be 3 masses and it is balanced by itself, that is A, B, C will be there and it will be balanced by itself, and you have to find any of the unknown forces, unknown masses from A, B, C. Otherwise, then in numerical it will be specified that there is 3 masses or 4 masses A, B, C, D, and there are 2 balancing masses to be placed in such a distance from the given masses, and you have to find 2 balancing masses. In either way, we have to fix a what is called as reference plane. That is the plane from which we take the distance from each of the planes of rotation. That is, the distance is L. L is taken from distance from reference plane. So easiest way to do is we have to fix one of the unknown masses as reference plane. So either Bx acting plane or By acting plane. So you have to mention it as Rp in your solution. Here itself you have to mention Rp. Or if you want to choose this one, then it which marked as Rp. Why we choose one of the unknown masses itself as the reference plane is that because we can take all the other distance, and in this column we will get a 0 value for the unknown masses. And we require that 0 value to solve this by digraphical method. So it is always choose one of the unknown masses as reference plane. So this is the theory part of this. The elaborate procedure of solving this will be seen in the next video, in which I will show you how to solve a numerical in this section. Thanks.